Hello friends and welcome to this e-learning course on chromatography. As we all know that Sheth M Science College Patan being the nodal center for this course under the umbrella of DIPAM Foundation is organizing this e-learning course for the participants who have registered in this 10-day course where different chromatography techniques would be discussed and made clear in the utmost possible way. So friends, I warmly welcome you on behalf of the Nodal Center to this e-learning course on chromatography. Now, before we move on with the details, let me introduce myself. I'm Dr. Deepkumar Joshi, Assistant Professor in the Chemistry Department of Sheth M Science College, Patan. We are affiliated to Hemachandracharya, North Gujarat University. Friends, the basic motive behind making you aware with chromatography is nowadays it has become a basic need in every industry as well as in every area of research. Friends, whenever we discuss the word chromatography, we always coin it as a separation technique. But mind well, it is a separation technique, but a physical separation technique. Physical separation technique. So, we can write it as physically separating components from a mixture. Several terms are involved when we discuss the physical separation. But among those terms, among those factors, the major part is played by stationary phase, mobile phase, and depending on the stationary phase and mobile phase, we come to a conclusion where two terms are introduced. Sometimes people try to explain by saying retention time, and sometimes they prefer the word retardation factor. We will make these two words clear in the due course of 9 days. But as of now, moving in little more details about the basics of chromatography. As and when we said just now that it is a physical separation technique, there are two types of separation that has existed. Mainly, they are classical methods of separation and modern methods of separation. Whenever we say classical methods of separation, these are those old methods which were invented way back but are still being used in several factors. Going into the details a little bit of that classical separation, let us try to see that separation of analyte from a matrix is a very vital step in science, and that can help in all the types of analytical determination. So friends, going into the detail of classical methods of separation, you are very much aware of three terms: precipitation, distillation, and extraction. Whenever you use the word precipitation, you know that it depends on the solubility product, that is KSP, and you come out with precipitation. After filtration of that precipitate product, you get the filtrate separate and the precipitate separate. So it is one of the classical methods of separation. Since long, we are using distillation and many small or big distillation methods. It is also a type of separating method, and most of the organic chemists have used now and then the method of extraction as a separation method. So these are classical methods of separation. Although classical methods of separation were there, but growing demand in the last 50 years have helped in emerging with the newer separation technique. And people consider chromatography, although it is older, but a newer method of separation which can help in reaching new and new horizons in the field of research and industry. So friends, historical development of chromatography. Whenever I'll go with an animated video in the course, I'll first show you the animated video and then we will discuss on the animated video. I request you to listen to the voice that is recorded along with the animated video very carefully.
Processes were originated from the work of Russian scientist Michael Sweat. In 1906, he has reported the results of his work on the separation of plant pigments. His interest was to find out whether the leaf extract, which is green in color, is having one component or more components. To check the number of components, he has developed a new method. He has prepared a glass column filled with powdered calcium carbonate. A petroleum ether extract of plant leaves was placed at the top of the column. It was found that the plant pigments were strongly adsorbed at the top of the column by the calcium carbonate. On further washing the column, only with petroleum ether, the pigments were moving down the column as two different zones having green and yellow color. Sufficient washing with petroleum ether was done to keep the bands apart. Then the column was dried and the adsorbent was extruded from the column. Individual pigment was then isolated by dividing the column of adsorbents into fractions containing various pigments. The pigments were dissolved with alcohol and recovered by evaporation of the solid. Although complete resolutions were not effected, it was great advance in the development of new separation methods and thus resulted in the method known as chromatography. Swett named the above process as chromatography after the Greek words chromatus and graphene, meaning colors and to write.
So friends, this was where from chromatography came into existence. Mikhail Swett, a Russian botanist, came up with the first experiment which led him to coin the word chroma plus graphene, together coined as chromatography, where his judgment, or rather to say his prediction, came to be reality. We all know green color of the leaf is because of the chlorophyll pigment present inside. But he had a judgment there it is not only a green component present inside the leaf, but there might be some other components along with the chlorophyll present in the leaf, and henceforth he made a ether solution of that leaf powder, and when he passed it through a column which was filled with an immobile part, which generally we coin it as stationary phase, calcium carbonate over here, the two components got separated. So this can be now considered as a modern method of chromatography. So this experiment perfectly justifies it to be a separation technique. Increment in the separation power. Mikhail Swett, pioneer in chromatography, came up with an excellent experiment. But the two extraordinary scientists, Martin and Singe, came up with gas liquid chromatography. The Nobel Prize in Chemistry in 1952 was jointly received by Arthur John Porter Martin and Richard Singe for the development of gas liquid chromatography. Gas liquid chromatography, when came in 1950s 52, was the first chromatography technique that used partition chromatography, or rather to say the phenomena of partition. You know, when a sample gets distributed between two solvents, we generally coin it as partition, and its value is coined as partition coefficient. People are also using the word distribution or distribution coefficient. So over here we can say that a total new era of separation chromatography emerged out suddenly in 50s by this extraordinary work of Martin and Singe. So friends, remember very well, when someone asks you who is the father of chromatography, it is Mikhail Swett. But when someone comes up with a question that who is the father of gas chromatography, Martin, Archer, John, Porter. Martin is considered as the father of gas chromatography. Now, from this experiment conducted by Michael Swett, we could clearly identify two phases. You could see that the ether that was added from the top moved to the bottom, and hence it was a mobile phase, a moving phase. But the solid powder that was filled inside remained immobile, remained stationary. Hence, the separation phenomena that happens in chromatography happens because of the two great working factors, and they are stationary phase and mobile phase. So remember these two words very clearly, stationary phase and mobile phase. Now, according to IUPAC, the exact definition of chromatography can be coined as: chromatography is a physical method of separation in which components to be separated are distributed between two phases, one of which is a stationary phase while the other is a mobile phase. They have written very well, one of which is a stationary, immobile, and the second one is the one which moves, that is mobile. And very important, over here it is mentioned in a definite direction. We'll come to this. Sometimes it is the direction of gravity, and sometimes it is the thrust of the pump that decides the direction. But definitions are meant to be learned properly for a better understanding of the concept. So, this was the definition of chromatography proposed and distributed among the fraternity by IUPAC. So, in principle, whenever we are clear with the definition of chromatography, we should be well versed with the principle of it. At least in the principle, a proper choice of two phases constituting of a chromatographic system permits selective adjustment of relative migration rates of the mixture components and of the extent of their eventual separation. It means over here, when you have a matrices or a mixture of components, they have to be separated by the minimum use of two phases, and we already know that these two phases are nothing but a stationary phase and a mobile phase. These components that are strongly retained by the stationary phase moves only slowly with the flow of mobile phase. So what happens over here? There are among the mixture few components that are moving at a slower rate, and there are few components that are moving at a faster rate. It is said in science that like attracts like, and therefore you can judge that among the two spots, red and green, in the experiment of Michael Sweat, one spot was moving slowly compared to other. So the spot that is moving slowly compared to other has higher attraction towards the stationary phase. And here comes the word retention. The time spent by a sample or a component or an analyte on the stationary phase is said to be the retention time. Remember very well, the time spent by an analyte, a sample, or a component on a stationary phase is fundamentally called retention time. If your sample or component is attracted more towards the stationary phase, it will move slowly, and a slowly moving particle always has a larger time and therefore has a higher retention time. So remember, if a sample is strongly retained by the stationary, then assume that it is spending more time and having more attraction with the stationary phase. In contrast, there are components that are weakly held and they do not stuck more with the stationary phase but move away. Always remember, mobile phase, although affects the sample, but has a major role of a carrier. As a consequence of these difference in the mobility sample, components separate into discrete bands. As we have seen, if there are two components, orange and green, both had a different tendency of attraction towards stationary phase, hence both get separate at a different time, and this is how a separation technique, chromatography, in principle can be discussed. Now, stationary phase in chromatography can be a solid, can be a liquid coated on a solid support, kind of a gel. And third one is something really interesting. We'll come to that. But when we say of solid, it is generally a porous material or an adsorbent having a very large surface area. And as it is porous, there are accessible pores where component can fit into. When we are talking of a liquid coated on a solid support, avoid shifting of a stationary phase due to mobility of a mobile phase. We mean to say that there is a solid stationary phase, and when a liquid is stuck onto it, it also becomes immobile. But there are some materials which are special, like immobilized polymers, small balls of polymers, surface bonded shorter chemical species. There are several chemical species which have small fragments of functional group, and they are considered over here as an extraordinary stationary phase in chromatography. Mobile phase in chromatography. Generally, when people discuss the mobile phase in chromatography, they restrict themselves to liquid or gas. But friends, make it very clear, there is no motive of restricting to liquid and gas. Even supercritical fluid like CO2 nowadays are used as mobile phase. Over here, what is the main motive of mobile phase, or how can you select a mobile phase in chromatography? The mobile phase that you are selecting in chromatography should always dissolve your mixture of samples. Mobile phase that is selected in chromatography should always dissolve your sample mixture, but should never dissolve your stationary phase. So remember very well, mobile phase should be of a capacity to dissolve the samples and the mixtures, but should not have even a little bit capacity of dissolving the stationary phase. It should have a property of separating and even eluting. At the end of this session, we will come to the word elute, elution, and will justify this term. But as of now, be very clear that whenever we are coining the word mobile phase, it is either liquid or gas or supercritical fluid. Classifying chromatographic methods. Whenever we think of a classification, always remember, it is not on one basis. There are several bases on which you can classify any method. Over here, when we try to classify chromatographic methods, we can classify it on the basis of physical shape, nature of mobile phase, your purpose of experiment, and mechanism of separation. Today, in this current video, as we are discussing the basics and introduction of chromatography, my main intention would be to explain each and every method that is associated with physical shape, nature of mobile phase, purpose of experiment, and mechanism of separation. So let us start in detail. First condition, classification based on purpose of experiments. Always remember, on the purpose of experiment basis, chromatography can be classified into two: preparative chromatography and analytical chromatography. Remember very well, when we say preparative chromatography, separate components for further use. It is used in such a way that when the components are separated, you can collect them in a little larger quantity and use them for further research, especially natural products. Requires in a large amount. So if you require the separated product in a large amount, you will require the sample in a large amount. Sample eluted is used further, to use further in research. But whenever you say that my purpose is an analytical purpose, it is only to identify and quantify the analyte in the given sample or the mixture. It requires a very small sample size, even up to 1 gram or 1.5 gram, and sample is eluted, is disposed. This is a major point. Sample that comes out from the bottom in preparative chromatography should be collected because it is used further, but the sample that comes out from the analytical chromatography is directly disposed. You cannot use it further because its quantity is very small. So this is how you classify the chromatography into two based on the purpose of experiment. Moving further, it can also be classified on the basis of shape, planar and column. Fundamentally, when it comes to planar and column, I always coin it that planar can be one dimensional or two dimensional, whereas column is a tubular thing So the sample can move zigzag, and henceforth I believe it to be three-dimensional. So whenever we classify it on the base of its physical shape, it can be planar, it can be column. But when we say planar, it is again subdivided into two, and that is paper chromatography and thin layer chromatography. Whereas when we say column chromatography, it itself is a technique, a very useful technique in separation science, column chromatography. And it can be further divided into the two best industrial upgraded versions, that is HPLC and GC. So this is how the classification of chromatography on the physical shape leads to two sub-major types, planar and column. Especially when we say planar chromatography or column chromatography, they have two different aspects of working. Planar chromatography, whether it is TLC or whether it is paper, you will learn in the later lectures that the samples move in the direction opposite to the gravitational direction. They move upwards, and hence it is called capillary motion. But in column chromatography, mostly they move downwards. Nowadays, people keep the HPLC and GC column straight flat, but generally we have seen keeping from top to bottom. So it moves in the direction of gravitation. But it is not always fixed that for GC and HPLC you keep it in gravity, but when you have a rational column, a simple column which is used by organic chemists in their laboratory to separate before sending the sample to spectrochemical analysis, it is always a column chromatography where the solvent moves in the direction of gravity. So if I stick to that rational column chromatography, it is the direction of gravity, and if I say planar chromatography, it is opposite to gravity, that is capillary action. So now moving towards the third classification method. But as I told you, before every movement that we will do in this series of lectures, I have collected few animated videos, and nature of mobile phase classification basis has such a wonderful video which we will see first in this animation and then move ahead.
Method is based upon the nature of mobile phase used for separating the components of a sample. As the mobile phase has to move through the stationary phase, either liquid or gas can only be used as mobile phase. When liquid is used as a mobile phase, the technique is known as liquid chromatography. And if the gas is used as a mobile phase, the technique is known as gas chromatography. The stationary phase has to be static in nature, that is without any movement, and hence either solid or liquid can only be used as stationary phase. In the case
Over here, you have listened to this animated video where it has been made very clear that over here liquid is used as a mobile phase, wherever over here gas is used as a mobile phase. But if you have listened carefully to the last line, the author said that stationary phase can be solid or liquid, but mind well, liquid over here means liquid coated on solid. So based on the nature of mobile phase, you can use two types of mobile phase, a liquid mobile phase and a gas mobile phase. And depending on this method of classification, you can come up with four combinations. One is a gas liquid chromatography, where gas is your mobile phase and liquid coated on solid is your stationary phase. On the bottom, you have a gas solid chromatography, where again gas is your mobile phase and solid is your stationary phase. Liquid solid chromatography, where liquid is your mobile phase and solid is your stationary phase. And liquid chromatography, where one liquid is a pure liquid mobile phase and second is a liquid coated on solid stationary phase. So classification that was based on the nature of mobile phase divided into four parts would also lead us to an extra information where we can say that if I am using gas chromatography, I must always have a column. Planar cannot be used because gas will diffuse out. If I have a liquid chromatography, liquid as a mobile phase, I can use both planar and column. Supercritical fluid, liquid, carbon dioxide, it always requires a column, and it also falls under the category of column chromatography, or over here a separate class of supercritical fluid extraction chromatography. But as of now, along with this information, where you have four combinations, you must also remember that whenever you say gas chromatography, it cannot be done on a paper, it cannot be done on a plate. You always require a pipe which is hollow, so it's a column. So it is always a column chromatography. But when you have a liquid mobile phase, you can use both column as well as planar. Classification based on the mechanism of separation. Friends, highly important slide. Chromatography, when classified on the basis of mechanism of separation, you have adsorption chromatography, you have partition chromatography, you have ion exchange chromatography, size exclusion chromatography, bonded phase chromatography, and affinity chromatography. Over here, among these type of chromatography, there are few chromatographic techniques that can be used for both planar and column, but there are few chromatography techniques which can only be used either for column or for planar. Technique number 3, technique number 4, always for column. Remember very well, ion exchange chromatography, size exclusion chromatography, always possible in column. If you have adsorption chromatography and partition chromatography, among these two, you can have both, that is column chromatography and a planar chromatography. Partition chromatography has always remained a point of discussion based on the distribution or partition coefficient. Friends, now let us move in detail of each of these mechanism that is highly anticipated. Mechanism of separation based on adsorption chromatography. We all know adsorption phenomena is a surface phenomena. So the mobile phase that is carried by separating analytes, or rather to say the mixture which is going to be separated by the carrier mobile phase, when passes through the stationary phase, if they try to separate on the basis of adsorption, how would it look? Imagine this white ball as the surface of stationary phase. So when this stationary phase is present and mobile phase is moving along with the components to be separated, the components will settle first on the surface of stationary phase, and afterwards they will move away from the surface. So it's a phenomenon of adsorption and desorption. So this is called adsorption chromatography separation mechanism.
In adsorption chromatography, the separation is based upon adsorption and desorption of solutes on the stationary phase and the mobile phase. Here stationary phase is a solid. Separation is due to a series of adsorption and desorption steps.
Here, if you look properly, you will get an idea that the phenomena of adsorption and desorption happens in a continuous chain, and when they happen in a continuous chain, they result into adsorption, desorption, adsorption, desorption, adsorption, desorption, leading to separation. So this was the first method. Coming to the second method, that is separation mechanism based on partition chromatography. But before going on to partition chromatography, I would like to draw your attention to one simple chemistry happening in the adsorption chromatography. When we say gas solid chromatography, or when we say liquid solid chromatography, in these two chromatography techniques, the mechanism that happens is the adsorption phenomena. What I told you just now, a series of adsorption and desorption will separate the compounds. Over here, mind very well, the polarity is very much important or a key factor in separation. As of now, remember this as a base because when we will be learning HPLC over here in the liquid solid category and GC over here in the gas solid chromatography technique, I'll make you understand the concept of polarity. But as of now, remember very well that whenever you are speaking the word adsorption chromatography as a mechanism of separation, it has much to do with the concept of polarity. Without polarity, I mean to say it is one of the important factor. Without polarity, you cannot assume regarding the complete theory of adsorption chromatography. Moving further, partition chromatography, as you all know, is a partition or a distribution of your sample between two layers, of which one is a mobile phase layer, one is a stationary phase layer. Majorly, remember, it's a trick that whenever you consider partition chromatography, most of the time your stationary phase is a liquid coated on solid. And whenever you say adsorption chromatography, your stationary phase is majorly solid. But whenever you say partition chromatography, your stationary phase must be or might be liquid coated on a solid. Let us listen to this very short animated video.
In case of partition chromatography, the separation is based upon the distribution of the solute between the liquid stationary phase and the mobile phase.
So here you can see that it was the phenomena of partition, the phenomena of distribution that happens between two phases, of which one phase is the stationary phase and the second phase is the mobile phase. And what I told you, remember very well, this stationary phase will be a liquid coated on a solid. I am repeating it again, liquid coated on a solid as a stationary phase, especially in partition chromatography, and a solid, especially as a stationary phase in adsorption chromatography. So I am quite confident that you are clear with these two mechanisms of separation, that is adsorption chromatography and partition chromatography. Mechanism of separation of partition chromatography involves, see very well, liquid supported on inert solid. I told you that partition chromatography, whenever comes into existence, always remember stationary phase is a liquid coated on a solid. Gas can be used, liquid can be used as a mobile phase. So, whenever it is partition chromatography, dear participants, liquid plays a major role as a stationary phase and it leads to gas liquid chromatography and liquid liquid chromatography. And henceforth, few minutes back, I have used a statement that partition chromatography has always remained a point of discussion. Over here, there are two important words, partition coefficient and distribution coefficient. I am not going into much details in this first interactive talk, introductory talk, because there is a long way to go with the description in detail of each chromatography. But there are few points that a UG student or PG student should know that I am discussing in detail. And whenever I am repeating it again because I know the purpose of repetition is a duty of a teacher when it comes to a better understanding of a student. Adsorption chromatography always involves solid as a stationary phase where the phenomena of adsorption and desorption takes place. But whenever you have a partition chromatography, you have a liquid support coated on solid which helps in the separation of components based on distribution or partition coefficient. Now, moving further, the mechanism of separation ion exchange chromatography. You know, in ion exchange chromatography, you have studied a very simple experiment since your school, removal of hardness of water. What you do, you have a column which is filled with resin which has sodium binded with it. So they are called exchangers. When you pour the water from the top, that water contains calcium and magnesium. As the water travels downward, the calcium and magnesium gets trapped inside and the sodium present inside goes into the water or goes along with the water. This is how ion calcium is replaced by ion sodium. Similarly, as I have used the word calcium, you can use the word magnesium. There are n number of applications of ion exchange chromatography, but as of now, we will be just discussing this one example in this introductory part. Let us see the video.
The separation is based upon the exchange of ions between the stationary phase and the mobile phase. The stationary phase has exchangeable ions.
If you see carefully, these pink positive charge ions, according to an assumption that I can make for this explanation, are those calcium and magnesium ion present in the water, and initially the red positive charge samples were into the column. So when the hard water is poured from the top of the column, the positively charged pink color calcium and magnesium gets stuck inside with the electrostatic attraction with the resin, that are called the ion exchangers, or rather to say the cationic and the anionic exchangers, and the red samples go down. So this is called ion exchange chromatography, and this is the mechanism of separation. Moving further, ion exchange chromatography. One of the best example is softening of hard water, calcium magnesium using EDTA. Second important thing over here, lanthanoids extraction. If you have seen in your BSc classes, we had an ion exchange method for the separation of lanthanoids. Over here, whenever we use the term ion exchange chromatography, ion exchange resin are used as an exchangers which are stationary phase filled inside the column. Electrostatic binding, a type of electrostatic force. There can be two type of exchangers. Cationic exchangers, they can exchange the cations, give sodium and take calcium. Anionic exchanger, give chloride and take sulfate. So it depends on what separation actually you want to do. Friends, if you remember 10 to 12 minutes before, I told you that there are few techniques that always requires a column, and there are few techniques which requires both column and planar, or rather they fit into both column or planar. Now imagine when you have ion exchange, how could you use planar? Planner can never be used. So you have only one option, excellent, and that option is column chromatography. So ion exchange is only possible when you have a larger version of a burette, which is called column. So ion exchange chromatography is always used in column category of separation. Now, mechanism of separation in the size exclusion chromatography. We know, we might have read somewhere that this chromatography or this separation technique is based on the size exclusiveness. That is, the separation takes place on the basis of size. If you look towards the picture over here, you can very well see that there are green color granules present inside this column. Now you know very well that a larger burette is called column. So this is your column. The green particles present inside will not move out. So that is our stationary phase. So these green particles are our stationary phase. You can see from the top, two types of mixture is coming down. A pink color ball and a blue color ball. Let us see among these blue and pink components as a mixture now, when passes through this column, results into what kind of separation. First we will look to this animation and then we will discuss.
Chromatography. The separation is based upon molecular weight of the solute and the pore size available on the stationary phase.
If you look carefully, the person used the word pore size. Over here, you had two types of components in a mixture. Small sized blue colored component and larger sized pink color components. Among these two components, the component executed as blue color on the screen were smaller in size and hence got trapped inside. And the pink color components were quite larger and were impossible to get trapped inside the small pore size, hence passed away. So this is how, based on the size exclusiveness, you can exclude larger size sample from smaller size sample. So remember, the sample size smaller than the pore size will get trapped inside, and the larger size will move. This is size exclusion chromatography. Friends, size exclusion chromatography is also known as gel permeation chromatography, gel filtration chromatography, and molecular exclusion chromatography. All these names relate to this one technique, size exclusion chromatography, depending upon its mechanism of separation. Over here, stationary phase is a porous gel with a specific pore size. As the mobile phase passes from the top to the bottom of the porous gel, larger size molecules pass through the void spaces, while the smaller molecules are entrapped inside the gel beads. You have a bead, it has a small pore, so the smaller size molecule will be trapped and the larger size molecule will move. So this is how, depending on the exclusiveness of size, larger size molecules are excluded and the smaller size molecules are trapped inside, and hence it is coined as size exclusion chromatography. Mechanism of separation for the bonded phase chromatography. Whenever you use the word bonded phase chromatography, it is directly related to a very simple word in our science. Like attracts like. If I have a polar surface and I have two samples, one is polar, one is non-polar, to this polar surface, from these two samples, the polar sample will stick and the non-polar sample will have less attraction. But now if I make the case different, I make this wall, I make this surface from polar to non-polar. And from two samples, the non-polar will stick and the polar will move away. So this depends on the bonding which happens with the surface. Like attracts like. If your surface is polar, among these two samples, the polar surface will stick with the polar sample. But if your sample is polar and non-polar, and your surface is non-polar, then among these two samples, the non-polar surface will have attraction towards the non-polar sample. So this is fundamentally a bond kind of thing. Henceforth, we coin it as bonded phase chromatography. First, we will see the animated video and then we will move further.
Reversed phase chromatography and normal phase chromatography. In reversed phase chromatography, the separation is based upon the distribution of the solute between non-polar stationary phase, which is attached to silica, and polar mobile phase. In normal phase chromatography, in which the solute is distributed between the polar stationary phase and non-polar mobile phase.
Friends, in this picture, it is very beautifully explained. If you see this silica, it is used as a binder for the attachment of the surface of column and your stationary phase. Silica is not the stationary phase. Silica acts as a cement to bind two items. Similarly, over here, the inner wall of your column must contain a stationary phase. But the stationary phase does not have the capacity to stick with the inner wall of the column. So silica plays that role. But if you see the outer part, these are the cyanide functional group, and N being highly electronegative with the lone pair of electron, it is a polar surface. So imagine like this. This is a column, it has this inner surface, and onto this inner surface you have silica, and on this silica you have your polar fragments. So now when you will pass a mixture of a polar and non-polar sample, the polar sample will stick with the polar fragments and the non-polar sample will pass away. So when this kind of phenomena happens, it is called a normal phase chromatography. But when you replace these polar fragments by non-polar fragments, your stationary phase will become non-polar, and that is now called as reverse phase bonded chromatography. So bonded phase chromatography can be subdivided into two: reversed phase chromatography and normal phase chromatography. Let us have a look. It is based on the polarity or the attraction. I told you we will come to this point. Polarity. We are in reversed phase chromatography. The surface is having a non-polar stationary phase. When the stationary phase is non-polar, it is called reversed phase, and when the stationary phase is polar, it is normal phase. Now, dear participants, you have a look on the screen and you might be aware, and if not, I am discussing that when your stationary phase is non-polar, your mobile phase is polar. When your stationary phase is polar, mobile phase is non-polar. Why to keep in an experiment the two opposite nature of stationary phase and mobile phase? It's a very simple chemistry. If I will have in this column a non-polar stationary phase, and if I will use a highly non-polar mobile phase will dissolve the stationary phase. We do not want mobile phase to dissolve the stationary phase, mind well. We want mobile phase to dissolve the sample and carry them till the bottom and allow those samples to stick with the stationary phase. So always think in a scientific way that when you have a non-polar stationary phase, try to use a lesser non-polar or a highly polar mobile phase. Whenever you have a polar stationary phase, always try to use a lesser polar or a highly non-polar mobile phase. So this is how, on the base of polarity, bonded phase chromatography, you can have two modules: reversed phase chromatography and normal phase chromatography. Friends, this is one of the highly used chromatography in the industries because somewhat HPLC mechanism and GC mechanism works on this. GSC, gas solid chromatography, and HPLC, if the column has a solid stationary phase, works on this phenomena. Also, mechanism of separation, affinity chromatography. Generally, this is used in the drug industry, in the biotechnology industry. See how. First we'll look to the video and then we will move further. But while looking to the video, remember or try to recall the lock and key mechanism that you have learned in your high schools or higher secondaries plus 2 classes, when you had the enzyme separation, when you had the biomolecule separation, when you had the catalysis experiment, like that. Over here, you will see the same. So first, let us have a look on the video and then move further with the mechanism of separation leading to affinity chromatography.
Is based upon the specific binding of one compound to the stationary phase, which will be only.
Don't assume all the pink balls to stick. But if you say completely, it's a shape selective chromatography, affinity chromatography. The pocket over here had a shape where this ball could completely fit inside, but the green or the blue color patches do not match it. So this can be used when you want to separate enzymes. If you have a mixture of 3 enzymes and you want to separate one, but you know that X enzyme has a capacity to bind with A but not with B, then A will become your stationary phase and you will pass X through it, with the condition that enzyme Y and enzyme Z do not bind with A. So it's a type of a lock and key mechanism where A and X will bind and the rest will flow through. So friends, a very rare used but a very important affinity chromatography in the world of biomolecules. Now, it is a highly selective type of chromatography that is based upon specific interaction between the analyte molecules and another compatible molecule immobilized on the stationary phase. Read it carefully. It is a highly selective type of chromatography that is based upon specific interactions between the analyte molecule and another compatible molecule immobilized on the stationary phase. So, over here, if I go back a little, the yellow pockets are the immobilized stationary molecules that are present, and the analyte molecules are those green color, blue color and pink color samples. For example, for the separation of antigens, an antibody may be immobilized on the matrices that forms a stationary phase. You have a layer of antibody on the stationary phase and you pass several mixture of antigen. The particular antibody and the antigen combination will stick inside and the rest will flow away. When the sample consisting of a mixture of proteins is passed through the column, only the specific antigen is bound to the antibody immobilized in the stationary phase. The same thing that I spoke is written here. Moving further, we are coming towards elution. Now, what was elution? You have to recall a little. If you remember the Michael sweat experiment where we started from this talk, once using a small sample, he filled the mixture on the top of the column. Then he took a wash bottle and passed a higher amount of ether from the top. This is called elution. This is called elution. Let us first see it in this animated video.
How two substances are separated in a column by elution process using a liquid as a mobile phase. Initially, a small portion of the mixture containing the components and the solvent to be separated is introduced at the top of the column. The components of the sample distribute themselves between the two phases. Introduction of additional mobile phase forces the sample down the column where further adsorption of the components on the stationary phase from the mobile phase takes place. At the same time, partitioning of components between the fresh solvent and the stationary phase takes place at the site of original sample introduction also. Continuous addition of the solvent carry the solute molecule in a series of continuous transfer between the mobile phase and stationary phase.
Friends, over here, if you see this experiment conducted initially using a dropper, a small sample of the mixture was made dissolved in the mobile phase and placed on the top. We know if that separated part has to be brought down, we require to add excess of mobile phase. So, if you remember this animation, in the starting moments, there was a orange color solution placed from the top using a dropper. That is a mixture of mobile phase and this sample. Afterwards, through this wash bottle that is now available on the screen, excess of mobile phase is added. Remember, this mobile phase added now and the mixture that was poured from the dropper probably has the same solvent. When such extra solvent is required to push the samples to the bottom to complete the phenomena of separation, we generally call it as the process of elution. But over here, according to the books, elution is a process of allowing mobile phase flow through the column to carry out the phenomena of washing under the effect of gravity or by pumping. Remember, mobile phase acts as a carrier, so it will just push the samples down. The phenomena of separation occurs by the interaction of your sample with the stationary phase. And it is so, henceforth over here it is written that in the process of elution, allowing mobile phase only to flow through the column to carry out the phenomena of washing. For carrying out the phenomena of separation, this white color stationary phase has interacted with that red sample and separated two components into pink and blue. So as I said earlier also, until we discuss in these 10 days of the course, up to what I am knowing or I want to make you know, always remember stationary phase as a material or as a factor responsible for separation. And always remember mobile phase as a carrier. Nevertheless, mobile phase has its own effect on the separation process. But we want to make understand you people, you participants, basics related to each technique. What I told initially, that I know that in a video of an 50 minutes or 60 minutes, it is not possible to digest complete chromatography. But we want to make you aware of what exactly are the basics involved in each technique of chromatography. Henceforth, it's a base to remember. It's the best thing to remember when you are just trying to go through each techniques. That stationary phase always plays a key role of interacting with the mixture and separating it into different analytes samples. Whereas mobile phase is a carrier. But into bracket, nevertheless, mobile phase also has its own effect on the samples. Friends, this is the basics of chromatography which I wished to discuss with you people in this initial lecture. Now we are on the verge of completion because we wanted you to know the terms mobile phase, know the terms stationary phase, know the term retention time. I know I am left with retardation factor, but it is coming in the day 2 video of TLC and paper. I am not going to discuss it here. Few of you, after listening to the video, might think that there is much more to say in stationary phase and mobile phase, but friends, for me, I had to divide the theory or the concepts related to stationary phase and mobile phase into 9 different lectures because I had every time ample opportunity to say on stationary phase and mobile phase. So when you will have all the 9 lectures in your mind at the end of the course, you will have a heap full of knowledge and information on alone stationary phase and on alone mobile phase. But the main motive of this lecture was to explain you or to show you it's a classification. How wonderfully it is classified based on the shape, based on the separation mechanism, based on the forces of attraction. So this is how chromatography, a very interesting topic, can be explained on the basis of its classification. Moving further, I would like to give you some references which we have used to prepare the presentations. These are few very well known and popular books that are used in analytical chemistry. Friends, this brings an end to our first video on the introduction or the basics of chromatography, where your main focus must be on classification of chromatography. Thank you friends for watching this video. For your feedbacks and queries, I am always open at my email deepgjoshi@gmail.com, and you can ping me up on my mobile number flashed on the screen. I have a humble request to you all to kindly visit this YouTube channel where you will see other videos too. But as of now, I am associated with this NGO, that is DIPAM Foundation, and fundamentally I belong to the state Gujarat. You will find many videos in our regional language. But continuously, gradually, we are also coming up with the videos in the English language. Once again, I thank you all for your patience participation in this first introductory talk on basics of chromatography. Feel free to give me your suggestions and feedbacks because that will help me grow in my area of academia and serve my students with better and better improvement. So, once again, I thank you all for joining me on this first video of basics of chromatography. Thank you.